As we know, that probability distributions are of two types, depending upon the type of the random variable. If the random variable is discrete, we talk about the discrete probability distribution. And in this module, we will be looking at how the discrete probability distribution look like and how to represent it in various different ways. So the probability distribution of a discrete random variable is a table, graph, or formula, as we know earlier. If we let the discrete probability distribution be represented by P of x, then the probability will be of each event or each outcome of the random experiment will be given as probability x is equals to small x. Here, you may want to note that the random variable is always denoted by capital X, whereas small x will represent the outcome or specific value within that random variable, which is the probability of a discrete random variable x to assume a specific value x. Let's take an example where a survey was conducted and respondents were asked if they have signed up for various food assistance program in the United States. This study was conducted in the Appalachian region of Southern Ohio. Here it shows the frequency distribution, where x is a random variable. And with this frequency, we can notice that there were 62 individuals who responded that they are enrolled in one program only. Whereas there were 11 individuals who signed up for eight various programs. Using this frequency distribution, we can construct a probability distribution of program utilized by families among the subjects. The first probability for number of programs 1, which is our random variable, is 0.2088, which is obtained by the frequency divided by 297, which is sum of the frequency. Here, this probability distribution can also be known as the relative frequency distribution. And all these probabilities at individual number of programs or individual x values can be obtained by taking their respective frequencies and dividing by the total of the frequency. Hence, this is the probability distribution. This probability distribution was represented in the form of a table, but the probability distributions can also be represented in the form of histograms. This histogram shows that for the outcome x, or for the random variables value 1, the probability is 0.20, and it's just above it, which is precise 0.2088. And likewise, each bar represents the probability of some specific value of that random variable. Discrete probability distribution can be represented by a function known as a probability mass function, which is usually denoted by P of x. When P of x is a function that satisfies the following properties, there's the probability that x can take a specific value is P of x, which is going to be a very specific value. All the probabilities are going to be non-negative for all the real values of our random variable. Moreover, the sum of the probabilities over all possible values of the random variable should be 1. So these properties help us to reach to the following essential outcomes: that the probability ranges from 0 to 1. So it can never be negative. Neither it can be more than 1. And sum of all the probabilities for all the values of x should add up to 1. Another type of distribution is cumulative probability distribution. And sometimes it's more convenient to work with the cumulative probability distribution of a random variable as compared to just the probability distribution. The cumulative probability distribution is obtained by successively adding the previous probabilities. As it can be seen in the expression given below, that it adds up all the probabilities which are assigned to the values which are lower than some specific value of x. So you keep adding. As you move forward, you keep adding the previous probabilities. Like in our example, we are given a probability distribution. To construct the cumulative frequency distribution, the first value will remain the same, but the next value will be 0.2088 plus 0.1582, which will be equal to 0.3670, and it keep adding up. As you move forward, it keep adding up the previous values, and the last cumulative frequency will be 1. Hence, this is a cumulative probability distribution. A cumulative probability distribution can also be represented by a curve. For a discrete random variable, it's going to be a step curve, a step function, which is also known as ogive. Cumulative probability distribution curve is a non-decreasing curve. It can be stable for the events or for the values of a random variable for which the probability is 0. But it would never drop down. It will keep increasing. Every probability distribution will have certain value of the mean and variance, which is given by these two formulae. Whereas the standard deviation is simply the positive square root of the variance. The probability function of a discrete random variable is called probability mass function. We will be discussing various probability distributions in our course. Few of them are Bernoulli distribution, binomial distribution, and Poisson distribution. Though there are so many other distributions which are available, but in our module, in our course, we will be talking about these three only. Thank you.